So one way to get them active was to use a question like this. And so I started, just asking what this is. Earth science class, we're talking about streams. And so a stream here with a low gradient, but a lot of water will erode. And you can see, in this case, I gave them the right... I'm going to stop using the laser. I gave them the right answer to this. And I'm not sure I should have. I have a suspicion, but at least for our purposes for today, it's good, because you can see that only 14% of the class knew this. This is real simple stuff. What I would then do is to show this slide, and then show this next one. And I'd say, write in your notes now, a description of this slide. Describe the gradient. How steep is that? Describe how much water is flowing through that. Imagine that these trees are about 35 feet tall. So you could imagine cutting one down and dropping it across the stream. You can get an idea. Describe that valley shape. Describe the shape of the stream channel that's in there. So I'm not telling them anything. They're looking at it. They're putting it in their notes. Doing the same thing then with this slide. These trees, however, are about 60 feet tall that you can see. So now imagine dropping one of these 60 feet tall trees across that stream. What is the gradient? How steep is it? What is the valley shape? What is the stream shape with it? And then go through it and then say, okay, well, what's the next? Then I'd say re-poll this question. And so here you guys can answer this. So a stream that has a lot of water but a low gradient will erode either downward or laterally, forming either a deeper canyon or meanders. And this is one where I just learned something new today, where what I should do when I was to do this is use that comparative slide and show what they did the first time then, and then what they were doing with the next one. We got 7 people in. Let's go with it. So, good. Most of you got it right that it is laterally and it forms meanders, which are those bends in it we talk about. Now that's not too tough, actually. That's a question that's sort of basically using some terminology. Here's another question, though, and this is a question where students bring this idea to the classroom. You know that aquifers are basically water that is under the ground. If you dig a well, you're going to hopefully hit water, and that water in that is going to be called an aquifer. So what do you think? Do you think aquifers are underground rivers? Okay. So, 38% said true, 63% said false in this case. Taking a real picture of underground rivers, or aquifers in a sense, is really tough. So, what we do is have some cartoon drawings, and I would ask the students in this, based on this cartoon drawing, 1, where is the shoreline? 2, how much relative water is there when you look at these sort of blow-ups of the area? How much water is there relative to how much rock? And so you start building some questions like this and start saying, okay, and you're I'm just trying to lead them to realize that this verbal description that we use of as underground rivers is actually really misleading, because there are no shorelines with it. There is a lot more rock in there than there is water. The water is moving, and it is under pressure, and it is usually still using gravity to move, but it can actually move against gravity, whereas streams are not going to be able to do that. Here's another good one. Raindrops are egg-shaped, round, teardrop shaped, variably shaped depending on size. You guys are figuring this out. We all know, if you see somebody draws a picture, there's a computer icon for a raindrop, what shape is it? It's always the teardrop shape. What that's conveying to us, though, is more than just the wrong shape. It's actually conveying to us how that forms. Because you're thinking of this dropping through there, and as it's forming here, there's friction, and you're thinking this friction's on the outside, and it's pushing this to back up to a point. And that's not what happens. If they're really small, they're round. If they're about a millimeter or so here, they're round. They start getting bigger, they start changing shape, and actually this 3 millimeter size here, they're starting to get this sort of indentation in the middle, almost look like a red blood cell. Finally, they get really big, and they have this sort of umbrella shape. You can imagine this is a shape that you have to imagine twirling that around on that axis there. And what's happened is you start getting, and you start to get these sort of teardrop shapes, and what happens is they break apart. And so they start getting over 4 millimeters, they're going to break up into smaller ones with it. So then we could go and ask them these questions again. This is one, actually, that I realized was one of the questions that realized where these misconceptions really came into play and why they were so hard to deal with. Because when I'd ask the students this question here, we have seasons because the tilt of the Earth, the elliptical orbit of the Earth around the Sun, sun flares, and fluctuations in solar output. Now, I know you guys are going to get this one because most of the students get it after reading about it in the book. And actually, I sort of like these types of questions too, because when I do these, really good. Okay, when you do this kind of question with it, you can talk about, too, how this is still the right answer. It's not necessarily the best answer with it, but it's still the right answer. And it's still, so in a sense, you're giving many more students, in a sense, a pat on the back with it. The other thing about this, though, is now we've got this. This is something they've read in their book. This is something that they can parrot back to you. However, you ask them then the next question about the mechanism for it, and say, why is it warmer in the summer than it is in the winter? And you give them some choices here. Concentrations of the sun rays during summer. Sunlight has less energy in winter. Longer days in the summer. Or we're closer to the sun in the summertime. And you guys will probably be non-standard responders. But that's all right. Maybe not. Anybody else want to go in? Good. You are not non-standard. You are standard responders to this. When we experience things, you experience something like the heat coming off of a candle. The closer you are to that candle, the warmer it is, right? We experience that all the time, day in, day out. That tells us that experience is telling us that must be what's happening with it. And so actually what I might do, here's another question that I ask, and you can see it gets sort of the same type of thing. Different wording of the question, but same type of ideas, and you still get, most of them are still answering the question wrong. There's only a few of them that are realizing that it's because of this concentration. So you start getting at the mechanism. What I would do then is to show them a slide like this or in a series of slides. First of all, I ask them, when it's summertime here, what's the weather like in Australia?